Hey there, welcome to another coding session. I've got my tea ready, and you know what that means? It means it's business time. So let's get down to business. I want to keep working through these features and cleanup, do some more on that. But the thing that I realized after last time was I put some of this sort of compound literal stuff into type check assignment because for compound literals we need to get the type from the left hand side, but then I realized that right hand expressions don't only exist in assignments, they exist in other places, and in those cases we haven't got something like this. So I think actually we might have to move this stuff into here before we type check the right hand side. So in this case we're just talking about the node. We're setting the type of the node and we're setting it to the expected type. I do think this is sort of a little bit backwards, how in compound literals we're setting the type and then we're going in here. It's kind of going against the grain a little bit, but I think this should still work, and it should work in more circumstances. I think it should still work. But now we have, I guess, a null type node. So what's the situation here? We've got an assignment, we're coming in. So I guess we're allowing scopes. So what is our right-hand side node? It's a compound literal because we came in here and we saw it was a scope. But now I'm a bit confused because if it was a scope, shouldn't we have got that error? Oh, maybe in this case it was already a compound literal. Okay. So I think we need to get rid of that, but also we need to go back to how we had it before. For some reason I thought that we didn't need it split out like that, but like this, so it's two if statements. So scopes become compound literals, but there might be some cases where it's already a compound literal. So then we do that. Let's try that again. We have the tests running, so it's probably going to be a while. Maybe I'll take the tests off for now. I do have to be careful with that. And we really do need to do something about the speed at which those tests run so that we don't have to keep turning them off. It's not ideal. But that was the thing that I wanted to just sort of clean up. We'll just, hopefully this will, yeah, okay. That succeeded. The next thing I'd like to work on here, it's kind of a continuation of what we did before. I mentioned this. So at the moment you can index and you can get the length of, and you can do boundless with lots of things. So for example, in here, this is a raw pointer, and I can just go like something like that. You know, so there's no bounds checking there because this is just a raw boundless pointer. If I go here, here's the definition. We see it's a boundless, so there's no bounds checking. But now that we can just take that pointer and turn it into a slice very easily, there's no need for us to be able to do this. So I want to be able to only index into a slice or an array, which is to say something where there is bounds checking. That's what I was trying to get at. Took me a while. My brain went blank there. So we're only going to allow indexing, requesting a length, and using the boundless directive with slices and with arrays. That's the idea. Now, how do we go about doing that? It's not to do with parsing. I think type checking is probably the first place we want to have a look. And it's type checking the primary. And specifically, indexing is definitely one of them. Eyebrow raise. We're not here for this at this time. Soon. So, I want to say that if we're trying to index something that's not an array and not a slice, then that's not valid. That's basically what I said before, eh? So it's kind of like this, cannot index type. I feel like normally we have these quotes, right? Ah, yeah, see, that one has it. So if there's not quotes, let's put quotes for a bit of consistency. Okay, so so we're saying we cannot index. So now we know that it is this or this. So we can simplify this business. And down here, we're saying it's not a slice. The only other thing it can be is an array. So we'll just change that to if it's an array. And because we know it's an array, we can go like this. So this code gets a bit simpler. So I think that's our indexing basically fixed. Do we want to limit what we can put boundless on? I don't think it matters so much. Boundless is only actually used, it only takes effect when we do indexing, and now we've limited what we can index. So if you put boundless on something else, it's just not going to have any effect. I think that's not a big deal. But speaking of boundless, where is boundless used? Where is it in the compiler? So we're looking for the Odin files. So another thing that I actually thought of was like this bounds checking could go inside, checking that it's above 0. I think there's only another place here. So these are legit boundless. Whoops. These are legitimately the boundless things that we're doing, and this here. So they're all actual bounds checking. But where else do we have it? So yeah, that's where I just changed. That's the standard library. This is legit. This here was to handle the case where we're talking about like pointers that are boundless. So I don't think we need to have that anymore, so we can cut that out. That's nice. Now there's one down here, which I was like not sure about. So this is when we auto dereference. So we could have a reference to an array, and then when we dereference it, we want to take the directive from that reference and apply it to the thing itself. I think that makes sense, that we can have a pointer that is a pointer to an array that's boundless. Will that actually work though? Will that actually work? Because here we're saying like we're getting the type node from the child director, the child node. So that's the actual array itself. Is that right when we index? Because we auto dereference. We auto dereference and then we get the child type node. Oh, because we're auto dereferencing the child. Yeah. So the child becomes the thing. Oh, and this is the index node. Yep, that makes sense. Okay, it's all making sense to me now. And that's why we needed to copy the thing to here. Yeah, I think that's legit. I might even take. No, I'll leave that there because it's still a little bit shaky for me, but I think it's pretty legit, and I think all of our usages of boundless and generation and in type checking are still good. So what about length? What about length? So here we're saying if it's a struct. So length, I think length we're basically saying could be on anything. So instead of that, I might even go for the old switcheroony. And put a case struct here. Then we can put a case, so I think that's all good. Instead of that, we can put a case. You can have multiple things in a case. So we can have a case array and slice. And then, what's going wrong here? I think this needs to be indented. There's some weird indentation stuff going on, but I think it's all good now. So as for a struct, we did what we did before. For these guys, we're going to do this, and this is the default case. There's an error. Okay, cool. So if it's on an array or a slice, let's add this while we're at it. We can do raw, which will give us a reference to. We've got it in generation already, something that kind of does it, right? Like if we go down to compound literal. No, it's not that. Is it? I guess it's in type checking actually. Type checking of compound literal. Here we go. Raw. That's adding type information to the raw for a typed literal. So now type node.children. So it's the child type node. So this is an identifier. It's a member. It's a member of a struct, or it could be a member of an array. So I guess we're talking about the child node here. Well, here we put it on the node. Yeah, because the node is the member. That's what we want to put the type on. I get so confused. but it comes from the child type node. The child type node is the child type node is the array. So its first child or slice. So its first child should be the thing that's contained within the array or slice, and we want a reference to that. Okay, I think that's right. So type checking. So we can have a .raw now, allegedly. So that should restrict length. So what we're talking about here. So we can only index on those things. We can only put length on those things. Boundless we can put anywhere, but it only takes effect when we're indexing, so that's all good. And then in generation, we should add a bit of code here that actually handles... Oh, I think it already does handle it. Raw and length. But only for slice. Because this is compound literal. Actually, what we want is up here. So if it's a struct, we do this. Okay, this is the part we need to change. Let's do another switcheroo since I love them so much. Like so. And we'll do case raw slice. Put that in there, and in the default case is an assert. Should cut that out, and hopefully that's legit. Okay. So now we need to be able to say where the raw is. And also this get length location, well, it should never come in here. It should never get to here. So let's just put another assert false just to make sure. Unsupported. Length location. Just something like that. So now, if the value is raw, this is also something that we kind of tackle up here, right? This. So maybe we can copy that down. I'm not sure how necessary it is to split this out, but let's do it anyway. I like the switches more. I feel like they're a more concise way of expressing. You know? Do you know what I mean? See, I can just like go like that now. And I want to do a similar thing up here. And that would be an unsupported raw location. And I'll just return empty, which should be the none location. But it's actually like, it's not that it's getting it, it's I mean, it kind of is. It's like either return the child location or a reference to the child location. And then at least up in this code, I took a copy of it. Because the address location is going to get updated. So that makes sense. Yeah, so I think in the case of a slice, we just return the container location. And in the case of an array, we need to do a reference. What's wrong with that? Undeclared name container type node. Pretty sure it's right here. Pretty sure. But something is not happy with this. I don't know why. So that's the container location, and we want to create a location. Put the reference in there. But we need to say what that location is, right? So what do we do up here? Address location. We created it from a register num. Still not really sure what the issue is here. Okay, it's changed its mind what the issue is. Okay, that's good. So then we can say context is a pointer to, where are we? Generation, a gen context. And then register num is an int. I probably should be using properly sized ints. It looks like we also take the file, which is an OS handle, I'm pretty sure. Okay, so it's a bit trickier, but that's how I get raw location. So we say address location equals get raw location. Container location is that. Context is context, register num is register num, right? So really that's like that. But container type node. So that's telling us whether it's a slice or a, a slice or the other thing. So that must be this, right? Child type node. So I'm pretty sure that's just like that. But that address location we need to copy into a register. If it's not already in one. File address location. Whoa. That's confusing. So register number What else do we need? It just says number. Type node. The hell is number? Oh, which register number? Yeah. So we shouldn't need this register number on the end. Is that enough like that? File, source, number, type node, context, optional string. I hope that's right. All of that just to extract this. I mean, was it worth it? Was it worth it? I don't know. Then we can do get raw location. Which is the file, container type node, container location, and context, and register number. Yeah, okay. Maybe that works. Maybe that works. I wouldn't be surprised if this has issues. Cannot index type. Yeah, see? Good. Should not be allowed to do that. I think I've done all the changes to the language that I need, but there's going to be a lot of this. So that's 219. I'm surprised that it actually made it all the way down to here. I guess there's going to be a lot of places where we have like, you know, boundless I8 like this. So maybe we can just change this to be I8 because it doesn't make any sense anymore to make them boundless. Right? So that's that. And then, was it 219? So one of these was a boundless I8. Well, we're passing in an I8. So I think I'm going to call this buffer. And that's going to be an I8 slice. And we're going to return an I8 slice. Okay. So let's replace that with reversed buffer. I do want to make an, like, I think we can remove this altogether, this buffer. I'm sure we don't need it, but I'm not going to try and do that right now. So that reverse buffer, so now we really see this string bytes. String bytes should be buffer, and that should work. We shouldn't need that. And then we can say buffer 0 length. We should be able to cut out this 0 at some point also. That's another feature we could do. Maybe add it to my list. Slice with only single index. I think I'll know what that means. Because it could be like this, or it could be, you know, like 5 like that, and then it would go all the way to the end. And this would start from the start, but we have to explicitly say 0 now. So now we return a slice which has the length in it. And I think that's better. We should get some issues now because like things are expecting slices and whatnot. So now if we go, so is there nothing that could be print line, I think. Is there nothing else in here that we could like improve while we're at it? This stuff all uses slices already, so that's great. Don't think that needs slices. These are just pointers to individual things. I mean, time val could be a struct, but let's not worry about that right now. I feel like we could get rid of these print Bs. I kind of want to make string an alias for I8 slice, actually. Because they're kind of the same, but that's a bit extra work. Unfortunately, I did them around the other way. A string is a length followed by a pointer, whereas a slice is a pointer followed by a length. So there's a little bit of work I need to do. But we can get there. So I think that's all golden now. If we go to like 135, just go slowly because maybe there's something in here we can improve. I think it's all looking, it's starting to look pretty good though. That could be plus equals 1. So I think we're around here probably. Well, 135 here. Because we're doing an I to A. Okay. So let's call this string buff. And we want to slice. Again, it would be nice if we didn't have to put these numbers in. Could just be a colon here. But that wants to be a slice, and then this is like the string. Slice, I guess. See, now it's like string slice dot raw and string slice dot length, but it would be nice, like in the future, I should be able to just pass the string slice in because they should be the same. Shouldn't need this B variation. Anyway, let's see if it's happy with that. Okay, so now it's saying 157, there's an issue. Because I'm passing in a pointer to an array instead of just a pointer to an individual thing. So I think I'm going to need to say dot raw. And our print B also wants the dot raw, I would say. Yeah, so this we can improve. Definitely the print B we can improve. Passing raw to a C procedure, that makes sense. So lucky I did add that raw because it seems like we need it. So then this would be dot raw and dot raw. I think print B. Yeah. All right. Now we have some dodgy assembly. So let's put that across here. 1562. Here we go. Whoa, look at that. We have double brackets. Yeah, that's a bit of an issue. So that's multiplied by element size. So I think when I was extracting that thing, I did screw it up. So multiply by element size and then offset, and then there's copy, and that's what the copy destination is where it is. So down here, depends if we're dealing with a slice or not, you know. Could be this copy. Interesting that there's none of this. And I don't think we're dealing with boundless. I don't think. Where is this? I to A. Yeah, we don't do any boundless stuff in I to A. Just before 4.1 end. So it'd be in here. So neither of these are boundless. They're just, it's a slice and an array. Which tells me that if it's doing a copy straight after the offset, we're probably talking about an array. So that we're not going into this slice business. So the copy then is probably will we return this memory of an address location? Okay. And the address location might be, I'll copy to, we should be saying address equals. Get location and copy. So yeah, I think that might be the error. There we go. Okay, how's your FPS counter look? Very low, but working. Yeah, sometimes these rogue windows, they stay open. And they do affect my FPS, it seems like. I guess they're still, it's a program that's still running. Yeah, much higher. Okay, so I think we managed to do that. I'm kind of stoked how that all just works. You know, we've got like, well, this .raw stuff obviously works. We've used it with arrays. I don't think we've used .raw with a slice. That's an array. No, that is a slice that we use .raw. It's printing out the FPS with it. Okay, so that's nice. Good, good. We've got another rogue window. Let's close this. Okay. So what was the thing that I wanted to do here? Well, that was making string an alias of i8 slice. That was the idea I had. We can cut this one out. And we're 40 minutes in. We could take a stab at this and see what happens. Where do we refer to string? Type checking, we create the type. Here we again add a type, and here we say the size of it. And then in generation, there is this business somewhere in here, f32s, x34s, strings. So this is where we get the data and the length, and then we define the string as the length followed by the data. So this is where we need to switcheroo, I think. So let's just commit. I'm just going to call it whip for now, but I'll change it later. And then we'll take a stab at it. So the first thing is this string. type here. We need to change that. So it needs to be string type node equals an AST node. We actually type is slice. And we need to append to its children looks like we need to put AST node in there. I'm hoping in my language we can omit this. I think at the moment, the way I've done it, we shouldn't need to have that. We can just put the literal and it just works. So it's a slice of I8s, basically. Yeah, so that defines our string. And then I did notice down here, I can understand for nil because there is no nil up in here. But we do have a string, we do have a C string, we have a bool. We don't have a number, so I understand that one also. But for these, I think I'm going to switch over, because especially the string, this is wrong now. So we don't need a pointer, but we need to get the identifier string, C string, and a bool. Okay. So I think that's, and this, this we don't need anymore because it'll resolve to a slice and we'll get the size from that. It's just an alias for a slice now, that's all it is. And then in generation, like I said before, we need to do a switcheroo. So I think it's just as simple as putting that like that. I do think that there's going to have to be some string handling difference, right? Like, surely when we generate a primary, so when we type check, yeah, that's right, we just add the type. But when we generate a primary, we go down to string. I kind of want to know what's going on here. So we created, and we just say string, yeah. I guess the only place actually that we use the string is here. And now that this is actually a slice, we can do away with this. And so this was the pointer. Then we can say .raw and .length. I think this will have to be untyped. Is that it? Oh, we need to do just message. So I guess we don't need that. Wow, it's printing out. But it could be write B that is printing. Although I think I said we don't need these anymore. So where do we have those? Example 137. So they should just be print line and we should just be able to pass the slice in. Is that right? We just passed the slice? Yeah. And I guess also from I to A. It's a bit weird, but when we pass it in, we'll pass it in as I8 array, but when we get it back, maybe we'll just call it string. They're the same thing, but it's weird to call this a string because it's really just a buffer. And I want to eventually get rid of this. This is how it's done in Odin, right? When I do I to A in my Odin code, then I have to do something like this. I pass in a buffer and the number. So it's the opposite order, the parameters, but it's the same kind of thing. So yeah, I should be able to just do print slice like that. I guess I could even just do this. And then 158. I guess that should be like print line. And we can just do log, info log. There is this length here, which I've been ignoring, but I probably shouldn't. So this procedure takes length appointed to an I32. So actually we can do info log dot length. That's nicer. That could also be dot length. And then we can say length is an I32 and pass in a pointer to length. And then we can take a slice that's 0 to length. Because otherwise we're going to get this massive string with a whole bunch of trash at the end. But this should give us exactly the right one. Okay, and we have a similar thing down here. I'll just pass in the same parameters. And we'll get a length here. I'll call it info log length, hey? How's that? Incompatible types at 157. I64, I32. Because I think the second parameter here is an I32. So I do want things like this to, I think I want them to be able to just be used as any int. But let's see, we'll just do an explicit cast we can do here for now. Maybe later we'll change that. So I think that should fix that. 159. Oh, wait a minute, that's already an I32. No, info log.length is an I32. But now this is one thing I want to change. This should not have to be an I64. I should be able to index with any kind of int. That I definitely want. Print b is not defined at 192. So this is a little bit tricky. I'll call it error buffer. We'll say print line raw equals error buffer and length equals 100. So that's really, we need a way to convert from C strings to strings. I mean, to find the length of a C string, you just need to find the 0, and then we could get a proper length. But for now, we're just going to use like this. This GLU error returns a pointer to an I8. So that actually should be correct. So this part here is interesting, actually. I'm just putting a literal straight in here. I'm not creating a slice object. I don't think I've done that before, but I just automatically did it then because it felt like the right thing to do. And this is where the changes that I made at the start of the session should matter, should allow this to happen. Let's see what happens. Unsupported byte size. I wouldn't be surprised if it was that thing that I was just talking about. Okay. So type node is slice. So we're indexing into type node is slice. So I think what that means is that we're creating a slice. So we've allocated a slice. And the end expression type node is a call. Huh. End expression type node is a call. Probably because it's this. Yeah? So actually we want the result of this. It's a place where we haven't done that. So end expression type node, that seems to be the only place that it's used. So actually we want the type result, and by convention I normally put result on the end here. And also for the start, we should do the same thing. Get the type result. Then they should work. There we go. All right. Wow. So the type system was happy with this. That's really cool, actually. That's really cool that I can just do that. Okay, so I feel like this is looking a lot better. This conversion here, I definitely want to get rid of. This 0 : should not need to be there. Well, the 0 should not need to be there. This conversion is legit, that one. Although a length, yeah, I think we'll just say, I think that's fine. We'll make the length as just I64, and if you want to change it to something else, you need to do that yourself. Converting from an I64 to an I32 is a no-op anyway. It doesn't cost anything. Yeah. Is there anything else in here that, any new stuff that I don't like? I mean, this one should just be a colon. So I think it's like removing those indices and being able to index with anything, index with any int type. I've already got that, and I've added that. So that's cool. Okay. Stoked. We got that sorted. So string is an I8. And like we're printing out strings, right? Like FPS as a string here. And then this I2A is like a string that we've created. So we've had created strings and also static strings, and we're printing them all out. That's amazing. I'm using slices everywhere. That's really cool. What else? I mean, we're under an hour, and there's a couple of things in here that I think are like quite easy. This one I think would be quite cool to do. Move sizes out of gen context, because it's something a bit annoying, and I noticed it before because we touched on it. This here, this data sizes map is in the context just because in Odin it's difficult to put a map up here. But I think we can cut this out. cut it out of the context. And then down here, yeah, in byte size of, we can just do a switch. I'll put this in here, a switch on the value, like so. And so I'll replace that with, I guess, a couple of tabs, case space. And replace that with colon space return. That can go there, and we'll put a default case. Why is it still... Oh yeah, normally the cases actually go indented to there. So the default case, or do we need a default case, or maybe we can just have an assert here, assert false, and return 0. Did I? I'm just wondering if I cut something out accidentally. I don't think so. I think these are all the types. But something we can do here a little bit differently is like all the ones, we can put them together. I8. And all the twos. So that'd be I16. All the fours, that's atomic. F32 and I32. This is a special 4. Let's put this down the bottom. And the 8s go together. And these are address sizes. And actually, these also are just like based on value. So like slice especially is address size plus 8. 8 being an I64. So that's a slice. And these are kind of variable size things, but they're still just based on value. This one's based on type, so that's a bit different. But these are based on value, so I think I might just put this as a case in here. So that's that. And then struct, I'll also put in here. Like that. So now reference is a bit special. It's based on type. If we have a type of reference, then we use address size. Otherwise, we base it on the value. And now we don't need it in the context, so we don't need to pass the context in here either. And yeah, so these don't need to take the context. I might split this out actually into multiple lines so it's a bit clearer what we're talking about. Like this is the element size and this is the length. So it's element size times length. Okay, and this I'm just gonna, I don't really want this, I don't really want to call things byte size anymore, so I think this is like the only, there's not many places where I use it. So let's just call that size. Okay. Now there's going to be a lot of errors because a lot of places call this, and now I've taken one of the parameters out. I'm going to go up slowly because I think there are other places where there's some other like utility procedures that don't need it anymore. So I can take them out. Probably a lot of the like copy. This is referring to data sizes when it doesn't need to. Like the copy. I feel like that probably doesn't need it. Copy stack address. Only needs it for these calls to like register and copy, which I've just taken it out of. Yeah, so a lot of procedures don't need context anymore. It's amazing how much I was getting passed around just for that information, that size information, which was not actually contextual, which is kind of why I didn't really want it to be in the context, because it's not actually contextual. Oh, is that why my errors are not showing up? I should have lots of errors. There we go. So let's take out lots of these. All over the place. Probably some out here. And here. I'm sure I'm missing a bunch, but I'm probably getting most of them. Copy to register. They should not need it. Here, context. Register. Where else? That's a copy, so that doesn't need a context. That doesn't need a context. Registers don't need it, and that's a copy, so that also doesn't need it. Register doesn't need it. I sure do like simplifying things. Might not be the most exciting thing to watch, but I enjoy it. Okay. Where are we at? There's probably some hidden ones in here somewhere. Here it is. Copy to register. Yeah. This guy, there's a whole bunch of them down here. And that one. Maybe across here. Just the one, is it? Okay, context. There's a whole pile of them in here somewhere. Funny how a lot of these errors show up differently. They're underlined differently, even though it's like the same issue really. All of them are just like missing parameters. But some of them seem to see it's like underlining just the thing there, but here it's underlining the procedure name. It feels a bit inconsistent. Oh, so here allocate probably does need the context. I took out too many contexts. I guess that doesn't need it. Byte size of, copy stack address, byte size of, Wow, just so many places it's getting cut out of. Cut that one out. Here. This here is a bit, wait, these two lines are almost the same. I should really extract them out and have less going on. That's kind of a bit duplicated. Cut these ones out. How are we looking? Is there one right down the bottom? Oh, there is two. Actually, is that the only reason this has a context? I think so. So get raw location, doesn't need it. There's one other place where I use get raw location. It's probably this one. Doesn't need it. Okay. That's a whole lot cut out. A whole lot of code cut out. Still works. Awesome. So we cut that out. We're a little over an hour. We could cut out these brackets. This one here was purely code. I'm just wondering, the stuff that we've done so far, do we need to add some more tests? We have some slice literal tests, right? I'm pretty sure we do. Yeah, slice from literal and a struct literal. Like these two we could do pretty quickly. Are there any other fast ones? I don't think so. I think it's just those ones are really fast. I mean, some of these would be pretty easy too. Like return bool from tokenize. If we go to our tokenizer, I mean, if we look for exit 1, maybe we'll just make sure that we're in Bangalang. Yeah, Bangalang source. Failed to open assembly file. Okay, generation does that. Main returning exit 1 I think is fine. Main can crash. Assert, that's okay. Well, that's Bangalang code. But generation tokenization I think should not. So instead, I would like to return a bool. So here, instead of crashing, we'll return false, and here we'll return true. And there was somewhere else in tokenization, right? When we read a string, we can fail. So where do we read the string? So if not read string return false, I guess. But I think we need to say what the error is, right? Well, we have the error there, don't we? So I guess it's covered. And there was one other place up here. Okay, I think that covers tokenization, although in main now, when we do tokenization, so when we compile, here's our tokenize calls. We need something like I think we can just say if not tokenize. Failed to tokenize standard. Failed to tokenize that, and here we can go boom, boom, boom. Failed to tokenize name. Like so. So we do still crash, but I just want it to be the responsibility of main to do crashing. These individual steps, they should just return balls. So that's why I want to tokenize to do that. So if I put somewhere in my code some invalid token, like a semicolon, which does not exist, yeah, failed to tokenize. Invalid token in file, failed to tokenize. So actually, normally we just say failed to parse with the file info, but we've already done an error with file info. So it's more like this, failed to type check. So I think it's fine just to do failed to tokenize, because we already have an error with this. Yeah, failed to tokenize. Okay. So we can get rid of that evil semicolon. Did we decide we wanted to do anything else? I think we're at 112 now, so we did that, return ball from tokenize. I think that's enough. So I'll pick another reasonable size one for the next session to start on. Hopefully we can nail a few of these. Oh, no, we haven't done that yet. But once we can get like all of these sorted, I think the code is just going to be... I might have a look through the source code of the compiler, just do like a little bit of a review and see if there's any other cleanup items to add. But I think this is pretty good. This is probably the most important cleanup. This is, when we go into our assembly. I don't know if we'll see it here, but it's not really so much of an issue here. I mean, we have like 3 F32s, which are 0, and 2 of them which are 1. So we have some duplication. It's not so bad here. But I don't want there to be any duplication, basically. Yeah. Okay. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.